All right, so leading up to the Chapter 7, 8 unit exam, or if you're reviewing Chapter 7 or 8, here's a few questions. This one is a logarithmic question here. This is number 15 from the cumulative review in the text, and I'll show you that here. That's on page 423 in McGraw-Hill Ryerson Precalculus 12 text is where we're from. Okay, so this one says the pH of a solution is defined as, now pH is the measure of acidity. So if you're going to take chemistry 30, we're going to talk a lot about pH, and in biology as well, environmental science, whatever you are moving into, pH is pretty important. It's the measure of acidity of a solution. And so it is defined in logarithmic terms. It's a logarithmic statement. So the pH is the negative logarithm of, and these square brackets mean concentration. So you'll, again, that's a chemistry thing which you will learn, but those square brackets here mean concentration of hydrogen ions. So, and it's the units are moles per liter. So the pH of a soil solution indicates the nutrients such as nitrogen and potassium that plants need to in specific amounts in order to grow. So alfalfa grows best in soils with a pH of 6.2 to 7.8. Determine the range of the concentration of hydrogen ions that's best for alfalfa. So awesome. So what we want to do is we want to put the each of these numbers separately into this equation and solve for the hydrogen concentration. So we need to know what the lower limit is for the hydrogen concentration and the upper limit. Or I should say, actually, you'll find out that this is the upper limit and this is the lower limit, but we're going to see that. So 6.2 is equal to the negative logarithm of the concentration of H+. Okay, so we need to solve for H+. All right. Might be a good idea to divide both sides by a -1. Okay, so we'll make that negative over there. And then when we have a logarithmic equation with logs just on one side, what you want to do is you want to rewrite this as an exponential. So this is base 10, isn't it? So let's go 10, remember what we do here, we go the base of the log to the power of this. So 10 to the negative 6.2 equals the concentration of hydrogen ion. Okay? And we evaluate that simply on our calculator. So we'll bring the calculator up here and we'll turn it on. That'd be a nice idea. And we'll clear everything away. And then we'll go like this. We'll go 10 to the power of negative 6.2. Okay? Negative 6.309, or sorry, 6.3 times 10 to the negative 7. So 6.3 times 10 to the negative 7. Now that's going to be in, what's the units there? Moles per liter. If you took Physical Science 20, you know what moles are. You haven't worked with them much, so that's okay if you don't remember, but moles are just a measurement of amount of specific substance, okay? Moles per liter. And that's of hydrogen ion concentration, okay? So that's one of the limits of the range. Let's look at the other one. So we'll go now negative 7.8, right, equals log of H+. And to rewrite that into an exponential statement, we'll go 10 to the negative 7.8 equals hydrogen ion concentration. So what's that on our calculator? And you know what? You can use this 10 to the power of the inverse there. I would encourage that. A little simpler, perhaps. And we'll go with negative 7.8. And that is going to be 1.58 times 10 to the negative 8. So let's go 1.6 times 10 to the negative 8 is the concentration of the hydrogen ion. Okay, so notice that this concentration here and this concentration here, these concentrations are the limits. So the range of concentrations of hydrogen ions, those are the range. And notice that this negative 8, this is smaller. That's small, and this is large in comparison. So we have so 7.8 is actually less acidic than 6.2. So small to large. So there's the range of concentrations. That's your answer for A. Now for B, says when the pH of the soil is above 5.5, nitrogen is made available to plants if the concentration of hydrogen ions is 3 times 10 to the negative 6. is nitrogen available? Okay, so we're given now a concentration, and we're asked where is it compared to 5.5? Is it above 5.5? So for B, let's just scoot down here a bit. I'll do B in blue. B for blue. Okay, so this is really easy. This is super easy. So what we do is we don't know what the pH is, and yes, that's a small p and a large H. That's how that's written. And we'll go negative logarithm of, and it's not a concentration, it's just a number, so you can use round brackets here, but 3.0 times 10 to the negative 6. Okay, does that make sense? Does that follow? pH equals the negative log of the concentration, so whatever that number is. Okay, all right. So this one should be pretty straightforward because all you do is you just plug in the number into your calculator. So we'll go negative log of, and remember how you do scientific notation here. You don't necessarily do times 10 to the power of. You have, oh, where is it on this one again? EE button. Where's the EE button? Oh, there it is, the second function. On this one, it's EE. You may have EXP, something like that. You may have a little times 10 to the X or something, whatever. But you use that button for scientific notation, okay? Okay, negative log of 3.0 times 10 to the negative 6. What do we get? 5.52. Okay, so pH is technically 5.5228. What was it? Oh, something like that. Is that what those decimals? Yeah, 2287 or 2288. Okay, let's write that. So when the pH is above 5.5, nitrogen is made available. So it appears that, now you have to be kind of careful because if you remember in science significant figures too, okay, hey, all these disciplines overlap, okay, they all overlap. Now, if you don't remember this, let me just help you remember. So look at, this is 5.5, that's two significant figures. Two significant figures. Really, in our answer, we can only consider two significant figures, right? So pH 5.5. Now, your answer to this question, you may say, yes, it is 5.5 or 5.52288. So it's a little bit above, but we can only be certain to two significant figures. So you may say, because of the precision in this question, we are unable to determine whether it's above 5.5. It may be above 5.5. It's close. I mean, whatever. You could say this. You could say, yes, nitrogen is available. You could say we are unsure due to the precision represented in the question. But again, if we're not talking about science at all and you just want to go with this as your answer, I think that would be acceptable. Okay? But if you've taken Physical Science 20 or even Chem 30 and you're taking this course, you would know, hey, my precision does factor in here. Okay, so that's the cumulative review. That's a word problem, a logarithmic word problem here. That's number 15 from your cumulative review.